So, in the previous session, we have discussed something about the transactions and how the transactions are being, what are the status of transactions and how those transactions are manipulated by using SQL. So, by using SQL, how they can be manipulated. And so, what are the different aspects of commit and rollback while executing these two different kinds of statements while doing work with SQL, as already seen. Today, we would like to concentrate on Savepoint first. Then we'll move to another very important topic. The topic is transactions asset properties. So asset properties are very important. So if you attend any kind of interviews in your final examinations, they will always concentrate at that explain about asset properties. So that is the first question which may be asked to you in the database management system. Okay. So therefore, you must concentrate for this particular class, because let me explain in a proper way how the asset properties are going to take place and what are the illustrations of asset properties here. So let me open this one. So EAMR class. Yeah, it has been logged in properly. Then we'll see how Savepoint can be operated as far as so these properties are concerned. Here, let us have a look here. Set lines. Let's also look into one small table. So I don't want to go in depth of the particular tables here. So small table. So select from CAT. So they might be having some kind of. Let me take a very small table. Otherwise, let me create a particular table. Okay, let me take rate, the table rate. It's very simple table. Set lines just 100. Yeah. So rate. Let me take that particular table. So select everything from rate. Okay. Look at this. No rows are there. Let me describe the table. What are the columns which are available within that particular table here? Describe RATE. So T and R, time and rate. Okay, these are the two different types of columns which are available. Let me introduce some data into this particular table. Okay, how the Savepoint can be gets created. Let us have a look here. How this thing Savepoint can be gets worked out here in the sense. So normally you people are gets operated some control Z in MS Office. Control Z is undoing the operation. So it is going to perform, so undoing the operation here. So here also we would like to perform some undoing operation, not exactly completely. So let me give you a small example, then you could understand very easily. So I have my SQL prompt seems like this. So here SQL prompt is there, and I have been operated several number of insertions. Let me say insertion 1, insertion 2, insertion 3, several number of insertions on one particular table, and followed by some updations. Several updations were done, several deletions were done here. For example, okay, 3 insertions were done by that particular by me on that particular table, and 2 updations were done, and 2 deletions were done. Okay, so far you did this one, and I did not operate any commit at this point. Now finally rollback can be, let me write RB, rollback can be gets operated. If you operate rollback, entire number of operations so far you did, everything will be gets cancelled. Okay, so here rollback in the sense undo. So in simple words, it is called as undo. So there is one restriction for this particular undoing here. What is the restriction here? So after some DML operations, some number of DML operations, how many number of DML operations it will be under your discretion. So after that, a rollback can be gets operated here. RB can be rollback can be gets operated here. So it could be considered as undo. Okay, it could be considered as undo. All operations what you perform here so far, everything will be gets cancelled. Undoing in the sense cancellation. Everything will be gets cancelled. Whereas second scenario, this is the first scenario where exactly undoing can be done. In second scenario, so for example, if you perform some number of DML operations, several insertions, several updations, several deletions, followed by after that a commit will be gets operated by you. So commit has been taken by you. Then after, so you have to take a rollback in the sense. So there is nothing should be happened here. The rollback can be taken. Nothing could be happened here. So there is no undoing because the operations what you have did so far with the DML, these will be so transferred to server permanently. Transfer to this particular server permanently. Here it is client machine. Here it is server. Whatever the operations you did so far, everything will be transferred to server permanently because of this particular commit. Then after commit, if you operate this rollback, nothing would happen because the client machine and the server machine have same copy. There is no difference in between these two. So therefore, cancellation or undoing cannot be done. Okay, cancellation or undoing cannot be done here. So these are the two scenarios. DML operation followed by rollback directly. It will be perform undoing or cancel the so far DML operations which were done. Second scenario is DML operations followed by commit and then followed by rollback. So nothing will happen because the client machine and the server machine do have same kind of data, same copy of data which is available at the server and the client as well. So therefore, after commit rollback only gets operated, there is no undoing or there is no cancellation. So that is what so you need to remember in terms of this one here. Now my point is already this point was discussed with you. This point was already discussed with you. Now my point is, if I would operate so 3 insertions, 2 updates, and 2 deletions after this so-called rollback can be gets operated, all these 7 operations will be gets cancelled immediately. They could not be available immediately. Okay. So I would like to perform same operation in phase-wise manner. How this could be done in phase-wise manner? Let me consider. So SQL, if you consider SQL here, SQL prompt here. So first insertion, second insertion, third insertion. So before going to perform these first, second, and third insertions, let me create a save point here. Save point for insertions has been created here. Save point for insertions has been created, and then perform several number of insertions. After this one, let me create one more save point for updations. For updations, one more save point will be created. Then update 1, update 2, update 3, update for several number of updates will be took place at this particular time. Then after, so save point for deletion has been created. Save point for deletion has created. Then you have to operate several number of delete operations. Several number of delete operations. Okay. So if this is the scenario, consider this is the scenario. Now, if you operate scenario number 1, first scenario I am trying to explain here. First scenario number 1, if you operate a rollback directly, everything will be gets cancelled. Everything will be gets cancelled directly if you operate rollback. Scenario number 2, even you have created several number of save points. If you operate rollback, everything will be gets cancelled. Scenario number 2, so if you operate rollback in another way, that is so rollback, RYLLBACK, rollback. So 2, TO2, one more syntax for rollback, that is rollback 2. some kind of save point here. If I would operate, this is the command here. If I would operate a rollback, let me write at this particular point RB DO RB2. So save point. Let me write save point. So delete. Save point delete. If I would operate this particular thing, okay, if I would operate this particular thing, obviously, so you would cancel only these kind of operations. These kind of operations will be gets cancelled. Okay, because you have been operated, so rollback up to this particular save point, up to only this particular save point, and third scenario will be rollback can be gets operated a rollback to so save point SPU under SPI for U. If you operate this one, so for example, this could be operated. So second could not be taken directly. Third could be taken. Rollback to SPU. So now all these things are going to be cancelled. So insertions will be as it is, updations and the deletions will be gets cancelled. Okay. So in this way, you can cancel your so-called number of operations on creation of some particular save points. On creation of some particular save points, you can cancel the operations here. So let us examine each and everything at this particular point. So using SQL, let us examine. Okay, here there is no data. So in this particular table, there is no data. Let me take some number of insertions here. Insert into RATE. So values. First value is let me take R, comma sorry T. I think first value is T. Second value is R rate. Okay, let me take this one. Time is some 6 months and 10%. Time is some 12 months and 11%. Oh, sorry, 12 months and 11%. Time is so 18 months and 12%. Time is 24 months and 13%. Okay, then time is 30 months and 14%. For example, if you look into this particular matter, so we have inserted approximately how many insertions? Insertion number 1, first insertion. So this is second insertion, third insertion, so fourth insertion, fifth insertion. Of course, only fifth insertions. 5 insertions have been done here. Select everything from so RATE. You do have 5 rows here. You please observe only 5 rows are there here. Okay. So I did not create any save point here. I did not create any save point. Okay. So I'd like to explain this particular scenario. I'm trying to explain this particular scenario. Okay. So I did not create any kind of save points here. So therefore, so if I would update, so update, let me operate some kind of updates here. Update, table name is rate, set R equal to some 10.5, where it is found. Yeah, 10.5, where rate will be equal to 11. I'd like to take so 10, 10.5, 11, 11.5, 12, something like that. Okay, one row was updated. And 11 where rate will be equal to 12. One row is updated. So 2 rows have been updated. When 11.5 where the rate will be 13. Okay, where the rate will be 13, I'd like to make it to 11.5. So again, you can see whether they will be take reflections or not, RATE. You can see, yes, previously it is 10, 11, 12, 13, 14. Now it is 10, 10.5, 11, 11.5, 14. Of course, 14 was not updated. Okay. Now, so 5 insertions, 3 updations. Updation 1, updation 2, updation 3. So 5 different types of insertions and 3 updations were done. Now, delete from so table name rate where so R equal to 14, for example, R equal to 14. One row was deleted. So 5 insertions, 3 updations, one deletion. Okay, now within this particular scenario, if I would operate a rollback, let us see how this could be gets happen. Rollback. So everything is completed. Then you will go ahead and select the data here. Select right here, no rows are there. Because so this deletion was cancelled, all these updations were cancelled, all these insertions were cancelled. What is the original status of this one? No rows at all. Original status is no rows. Okay, 5 insertions, I mean, 1 deletion was cancelled, and then for 3 updations were cancelled, and finally all insertions also cancelled. So if you would operate something like this in this particular scenario, something like this, some insertions, some updations, some deletions, followed by rollback, in the sense everything will be cancelled. Everything is cancelled. But my intention is, let me introduce again the data here back. Okay, so time is actually 6 months, 10%, for example. Again, time is 12 months, so 11%. Time is 18 months, so 12%. Time is 24 months. Oh, sorry. I'm very sorry. So I must create a save point here. I must create a save point. So let me create a save point at this particular point. Before going to create the save point, let me check out this particular data. Select everything from rate. Look at this. Look at this. No rows are there. So status of this particular thing, status of rate table will be so nil. Nothing is there. Now I'd like to create a save point for insert. Save point. Let me say INS. My save point name is INS. Now I'd like to go for insertion. So 6 months 10%. Then so 12 months 11%. Then 18 months, that is 12%. Then so 24 months, that is 13%. Then what do you call 30 months, and then 14%. Okay, you can see this one. You can see this one. Let us so select this particular thing. Select everything from so rate. Yes, all insertions are gets over. All insertions are gets over. Now let me perform updations. Let me perform updations here. So before going to perform updations, let me create save point followed by its name. So my save point name is UPD. UPD is my save point name. Update UPD. Okay, that is my save point. Yes, save point was created. Now update table name is rate set. What is the value we are trying to set here? That is R equal to 10.5. Same operations here where so R equal to 11. Where exactly R equal to 11? So you have to change. So 1011 to 10.5. Yes, one row was updated. And same thing. So 11% where R equal to 12. Second updation. Okay. Then so 11.5 where it could be 13. Yeah, third row is updated. So 12% where R equal to so 14. Okay. So look at this, all updations are took place or not. Select everything from rate. Yes, everything has been taken place. Okay, everything is good. So save point name is UPD, insertion save point name is INS, and then now let me go ahead and create one more save point here. That save point is save point. So DEL, delete for deletion. The save point is DEL. Okay, one more save point was created. Now I would like to delete at least 2 rows. Delete from so rate where T will be equal to 30. T will be equal to 30. One row was deleted, and then T will be equal to some 6. Okay, 2 rows were deleted. Now take this particular select everything from rate. So look at this. Those 2 rows have been deleted. Now 5 rows will be shortened with 3 rows. Okay, on elimination of 2 rows, it has been shortened to 3 rows. So we have created 3 different types of save points: INS, That is the first save point which we have created. So then UPD, second save point which was created, and then DEL is the third save point. Now I thought that deletion of so time equal to 30 and time equal to 6 is actually not legal. It was unknowingly it was deleted. So therefore, I'd like to cancel only these two operations, only deletion operations. Then how could you get cancelled here in the sense? So ROLLBACK, previously we have been operated like this, but right now we have created some save points, So roll back to, what is our save point name? DEL. DEL is the save point name. Up to this one you have to delete, roll back. Look at this. Those two deletions have been cancelled. This operation and this operation has been gets cancelled. Now you can select the data here. Yes, you got the data back. You please observe this one. Okay, you got the data back here. Now these modifications, updations also 10, 10.5, 11, 11.5 also accidentally done. So these are also not legal. They are accidentally done. Then how could you roll back from them in the sense roll back up to UPD. Okay, so UPD in the sense here it is 10, 11, 12, 13, 14. That is actual data in rate, whether they will be affected or not. Let us see. And go ahead and select the date. Yes, everything will be gets cancelled. Okay, everything will be gets cancelled. So we are doing the cancellation at phase wise. And then one more save point is there. That save point is insert. INS is the save point. If you gets cancelled the insert, every data will be gets removed because all insertions will be cancelled. So if you cancel the insert operations, obviously everything will be gets cancelled. So therefore, again it will be come back to the original form or original snapshot. So let me operate ROLLBACK to INS. Let me consider this one here. Everything is rolled back. Okay, then you have to select the data. So this is the original form. In this way, you can phase wise, of course, I have been explaining to you so that I have been operated this update, insertion and deletion simultaneously, but people could not be, in real time, people could not be perform these operations in hurry up manner, okay? So they could not be done in such a fashion. So therefore, in this way, so this save point will be gets operated. Okay. Then moving towards asset properties. Look at this. When transactions can be gets executed, you have to remember every transaction must be so follow these property rules. A transaction must be follow these rules while they are being executed. So these rules must be gets followed by every transaction. Then only the transaction will be produces consistent state. Otherwise, so if any transaction is not following these properties, so transaction could not be get. The database could not be get a consistent state. It might be in inconsistent state only. Then what are the acid properties? A in the sense in acid, A in the sense atomicity, C consistency, I isolation, and D durability. So look at this. So these are very important to maintain the integrity of database during integrity in the sense maintaining one consistent state to another consistent state is called as so integrity. Integrity does means maintaining one consistent state to another consistent state. So that is called as integrity. During transaction processing, these properties must be get followed. First one is, look at this, atomicity. Atomicity in the sense, normally transaction does have many number of database operations, right? Many number of database operations. But if you consider all those database operations will be bundled within one name, that name is called as a transaction here. Okay, transfer 50 rupees from my account to some other account. So that what kind of operations you are supposed to perform to fulfill this operation, So then those all instructions will be called as one transaction. Okay. So this transaction must be executed in single unit form, single unit of operation. Entire transaction will be gets executed. Okay, that is the meaning of this one here. So you can execute entirely or not execute at all. Okay, so for example, a transaction has been defined something like this. So first instruction, second instruction, third instruction, fourth instruction, and so on. Some 100 instructions are there. All these 100 instructions will be considered as a single transaction, right? If you want to execute this particular transaction, execute 100 at a time. Execute 100 at a time. Okay, then whole transaction will be executed at a time. Otherwise, if any interleaving procedure will be there, don't execute this transaction. You just put aside. That's all. Then, so atomicity will always suggest to you don't execute the transaction in partial way. Partial in the sense out of 100, some 20 will be executed, then it could be stopped. Another 20 will be executed, then it could be stopped. Don't do something like that. Okay, you have to execute 100 at a time, or so you have to put into ready queue for waiting for some more time for getting 100 instructions could be executed at a time. Okay, execute entirely or do not execute at all. So this is the slogan of the atomicity. Then consistency. Once a transaction should be executed, so this is the very important point we need to remember. Once a transaction can be executed, the transactions will be causes to move from one consistent state to another consistent state. One consistent state to another consistent state. It must be very important. So consistency in the sense on execution of one particular transaction. So it should be the database must be moved or the database must be take one consistent state to another. Okay, already I have explained. We have taken this particular kind of issue in the previous things itself. Okay, in the previous sessions itself we have taken. Okay, what is the consistent state and what is the inconsistent state? Already we have taken. Then isolation. When any transaction is being executed, no other transaction can be so interleaved. Interleaving. Let us take what is interleaving after some time. In a couple of minutes, we will take what is interleaving here. Okay, so no transaction will be interleaved. Everything isolated in the sense alone. Isolation. The dictionary meaning or literature meaning of isolation is so alone. Okay, alone it could be gets executed. No interleavings could be gets taken into consideration. Okay, during the concurrent execution of a thing, intermediate results from simultaneous executed transactions should not be done here. That is what the isolation does means. Then durability. You have to allocate the CPU. You have to allocate the CPU for entire execution of that particular transaction, whole execution of that particular transaction. So such kind of thing is called as database durability. Database durability. So these are the 4 different types of activities which are very important for any kind of thing. Atomicity in the sense, entire transaction can be executed at once and no partial executions will be entertained. That is atomicity. Consistency in the sense, on execution of one particular transaction, so the transaction must be taken one consistent state to another consistent state. Isolation in the sense, no interleaving can be happen in between. While executing any transaction, no interleaving can be taking place. Durability in the sense, CPU must be allocated time to the transaction for completion of entire instructions within the transaction. So these are the 4 asset properties. It's very important. Now let us see. How could you write the transaction here? Already we have taken a transaction must be get starts with So begin transaction and ends with end transaction. Where in between these two, yes, you can execute any number of basic operations for one particular transaction here. So look at this. So I wanted to perform the bank transaction from account A to account B. So 500 rupees will be get transferred. How this could be? So look at this. You have to take old balance and a new balance will be equal to old balance minus 500, and then old balance will be updated to actual balance of so-called account A, and then you have to commit it. Then close your account A. Then open the account B, and old balance will be taken from account B again, and you have to add the 500 to that particular balance, and then so update the same, and then apply commit so that it could be completed. These are the operations which we have to perform. On the other hand, so let us take one more thing, that is transaction. This transaction T2 is intended to add some 1.5 what do you call interest rate of interest to account A and account B. Okay, so therefore these are the operations which could be done for account A, and these are the operations which could be done for account B. Okay, however, you can perform set of legal instructions to achieve whatever the actual goal, whatever the actual business logic you have to apply here. So in this way, you can write your transactions. Then, when you have to operate this particular read item, what could be happen? What is the actual operation could be done? Normally, your item, your X, whatever the value you are looking for, that particular X is being stored somewhere else in our disk. Okay, read item will be always looking forward. So it is find the address of disk block. Find the address of disk block. Let us consider. So here we need to consider three different areas. This is, let me say, this is a disk block. Let me write DB, and this is random access memory RAM. So RAM. So let me consider this is our actual element to be processed, that is X. So this is the disk block where exactly X will be there. Okay, this is the disk block where exactly X will be there, and that particular disk block is going to identify this particular disk block is going to identify and read out everything and place it into memory, random access memory of that particular system. Within this particular disk block, so you do have one particular value, that is X. X is available somewhere else here. This is the value of X. This is entire. The blue colored thing is the entire disk block. Within that we have X. X will be copied from random access memory to your program location. This is the value of X. Let me say that is 10 or 20, whatever it may be. It has been copied. Okay, so these are the three operations which could be done when read item is going to perform by operating system. First of all, it is auxiliary storage device. Auxiliary storage device in the sense hard disk. So HDD. In auxiliary storage device, it could be identified where exactly this X has been stored. What is the block number? Identify this whole block and copy this whole block to random access memory. And within that particular copied block, identify the address of X. We need only small content, that is 10 or 20. Only that particular value is required for us. That value can be identified. That could be placed into so our actual memory. I mean actual program. So variable. These are the three steps which could be done here. When write item is being operated. Before write item, read item can be there. Then already this buffer is available. This block is available at random access memory. There is no problem. Before so write item, if you are not operator read item, it could be performed three operations of read again. Then so store this particular value. This value, whatever the updated value you have taken, that could be stored in random access memory. Okay, and after that it could be written onto the disk. After that it could be written onto the disk. But for our convenience, write item will be divided into two operations in terms of explanation point of view. One is write item, and second one is commit. So commit will be always used to takes place for make the transaction permanent. So that for explanation point of view, I have been taken this commit also into account. Okay. So these are the four operations which could be done by write item. These are the three operations which could be done by read item. Let us consider some kind of transaction here. Read x equal to x minus 1, write x. Read y equal to y plus n, write y, and so on. So transaction 2, this is available at a client 2. This is available at a client 1. So these are the two transactions. How could you write, how could you execute these two transactions? Let us see. So first transaction will be executed completely, then followed by second transaction. What does it mean? So transaction 1 followed by transaction 2. This is one particular kind of schedule. Another schedule will be, so transaction 2 has been executed completely, then followed by transaction 1. So it could be considered as a transaction T2, so is followed by the transaction T1. Either of these two schedules are okay because isolatedly acid properties will be gets followed completely. Durability is there, isolation is there, and then everything, consistency will be there, everything will be there. But you can take here, so look at this, transaction T1 is interleaved by transaction T2. Two operations of transaction T1 followed by two operations of transaction T2. Again, two operations of T1. So there are no two operations, one operation of T1, then followed by and so on. Otherwise, like this also. Okay, here also three operations of T1, three operations of T2, three operations of T1. So likewise, we have many number of schedulers, user number of schedulers. We would like to take this particular kind of scheduler into account, and discussions will be made based on this particular scheduler. What is the problem of this particular scheduler will be discussed. Okay. So what are the side effects of transactions? What kind of side effects which is being maintained by the transactions will be discussed by tomorrow. There are two different types of side effects. Okay, let me take some other time because the time is going to lapse. Okay, let me take your attendance. Please wait for a while. So two side effects are there. One is a dirty read. Already this particular problem is there with you in operating systems, which is called as a race condition in your operating system, which is called as race condition. And second one is incorrect loads. These are the two different types of problems whichever been there with us. So we shall discuss those problems and how those two problems can be overcome.